Hello, my name is Damon. I'm a developer on the config crew. The config crew are currently working on developing a tool called FireFind. FireFind is a firewall analysis tool that's designed to ingest large data sets of vendor configured firewall policies and analyze those policies against a curated rule set that's designed to highlight vulnerabilities or flaws that may exist in those policies that are exposing a organization to cybersecurity risk. Firewall is vendor agnostic, so FireFind is vendor agnostic. What that means is it will know which firewall vendor it's dealing with based upon the data that it ingests. It's a lightweight script, as I mentioned. In that spirit, we've opted for a layered architecture approach, as you can see from the image in front of me. So when we have really sat down and figured out how to design the tool, we sort of said to ourselves, FireFind at its core, it's designed to ingest data, parse that data, analyze that data, and produce an output for a client to review further or process further. In that essence, its core functionality we've packed into a service layer. So the service layer includes a parsing engine and a rule analysis engine. The parsing engine bears the brunt of determining what type of file it's dealing with. At the moment, it'll do CSV and XLSX. It'll hand off the policies as it grabs them to a rules analysis engine, which will have a look at the curated rule set that we have and determine whether or not that rule is vulnerable, and generate that into what we call an output artifact, which is sort of a pseudo layer. It'll have a PDF report for non-technical stakeholders and CSV output, which is machine readable for further processing. So with a sort of an agnostic service layer, we're able to build a presentation layer on top of the service layer that really has any sort of user interface that we need. One of our core requirements is a script. So what we've opted to do is create a command line interface tool to sit on top of the service layer. One of the optional requirements we have is to provide a web UI for users operating in the browser. So having an agnostic service layer, we can actually fit both of those UIs into the presentation layer. In addition to our service and presentation layer, we have a small persistence layer. The persistence layer, has some lightweight YAML files, all file system based, which contain things like our configured rule sets, our engine configuration, configuration that feeds into our presentation layer. So it's accessed by all of the layers that we have. And very important down the bottom is our business logic layer. So the business logic layer contains all of our data models and classes, which represent things like different firewall vendors, what represents a rule policy, what represents a rule violation. So this sits in here, purely data-based, and feeds our service layer. So as I mentioned, a lightweight script. I'll jump into a terminal now to give a small demo of the prototype that we've developed in the first sprint. So FireFind, I'm going to interact with the CLI tool for this demonstration. It's written in Python. We chose Python because it's a lightweight framework, lightweight programming language. It doesn't require any complex runtime dependencies like in Java runtime environment, .NET. It can be run easily from the terminal as well. We've used Poetry as a package manager and installed FireFind as an installable package, so we can run it just using the FireFind commands. You can see the prompts there from commands I've ran earlier. That, for example, FireFind version should give us what version we're currently sitting on. So I'll just run through a few commands to demonstrate what we've got so far. FireFind, essentially, we will be ingesting large data sets. So I've got a test CSV file up here with about 10,000 rows of data. That's designed to basically trip over on one rule as a bit of a test for this demonstration. So for analyze, we've come up with quite a simple command, which is FireFind analyze. We set FireFind analyze, we target the file that we want to ingest. Now, we can specify a vendor or we can leave vendor out of the command. Leaving vendor out of the command will trigger the vendor detection logic that we've got in the parsing engine. But at the moment, that's not fully developed. So we have provided the option to target the vendor. So effectively, if I run this, what it'll do is it'll grab test CSV, it'll iterate all over the 10,000 records. The rules engine will analyze based upon the rules that we've got, and it'll produce some readable output, hopefully. So the analysis engine, as you can see, runs quite quickly. It completed the analysis process in 0.11 seconds, and it found 2,520 violations, which is quite a lot. In the test CSV, I've basically set it up so that every fifth rule will trigger a violation, and that's just for some load testing that we were doing. So effectively, when this happens, it'll write a PDF and a CSV file. So if I jump up here, you can see the CSV file that it's produced. So it's basically giving us some details of all of the rules that it's got. At the moment, only one rule fails just for this prototype. So we'll have 2,520 violations in here. And it also produces a PDF file. I'll just dump into a file to display the PDF file that gets generated. So our PDF file basically sorts them into violations by severity, and it'll give us a list of our top findings as well. So the rules that we're using to analyze with FireFind at the moment are just a dummy rule set that we've sort of identified as, what will be high risk rules. What we've built into the tool is the ability then, rather than going into a YAML file and having a look to try and find the rules and edit the rules, is we've exposed through the CLI tool a way that we can edit and interact with the configuration layer. So if we type in FireFind config show rules, it will give us a list of the currently configured rules along with their ID. So with these configured rules that we have, one of the requirements is that we're able to enable or disable rules. We thought, rather than again going into a YAML file to do that, we'd expose that through one of the command line layers as well. So FireFind config set rules. One of the IDs I've been using for testing is just the first one, which is SSH open to world. Oops. And through this, we can change the state. So at the moment, the rule is enabled, obviously, as it caused our 2,520 violations. So actually, that's too many violations. We want to disable it. So we run it, disable it, updating rule ID, setting enabled to false, successfully completed. So if we go back and we now run our analyze command again, hopefully this time we get 0 rules violations detected. And there we go. So analyze 10,000 policies again in the same time and no violations found. So we've made that fully configurable. Changing the state of a rule is not the only thing that we're going to expose here. We've actually allowed pretty much any of these except for the ID to be changed. So a user can change the severity, they can change the description, they can change the rule name, and obviously the state, as I demonstrated earlier. We've also exposed an interface or an API to allow a user through the CLI to change the core configuration. So I've got a small core configuration test file here at the moment. So as we saw before with the output, the analysis output went to analysis.output. Say a user wants to change the default path here, and they don't want to provide a path in the command itself. The user can do that by simply going with FireFind config set output and then provide the path that they wish to go. So for example, at the moment, I'll just do test, setting configuration, update defaulted path for the analysis output, close the file down and just load it up again. And we'll see that the output path for both CSV and PDF have been changed to test. So the idea going forward is that we build upon that layer and make the engine or the configuration fully interactive. So a user can just pretty much change the state, set configuration, get configuration, do what they need through the script itself, and analyze as well, obviously, which is the core of the application. So I hope you enjoyed that small demonstration and an overview of the architecture that we've used. I'll cut this short for now. Um, and I'm really looking forward to showing everybody what we can do with the rest of the FireFind tool. Thank you very much.